The electric slide. Fellas, make sure that you do not leave middle school without knowing how to do the electric slide. As sad as it is, it's the cha-cha slide of about 20 years ago. But they're still playing it everywhere. The electric slide, everybody. We could not get through this unit without it. Alright, so we're combining two goals here. We're going to combine goal 4 and goal 5. So in goal 4, it is all about drawing circuits and being able to use the correct symbols and being able to illustrate a series, a parallel, and a simple circuit using the symbols. If you're going beyond that, you are able to predict what will happen to the flow of electricity when a circuit changes, like when a switch is open or when a circuit becomes shorter. So being able to explain what's going to happen when the circuit changes. In goal 5, we're looking at the pluses and minuses of parallel and series circuits, advantages, disadvantages, which one should you use, why should you use it, and then at a level 4, you're able to defend the stated advantages and disadvantages. Basically, you're able to prove it. Here we go. So, a simple circuit, we know what a circuit is. It is a path of electricity, and if it is a complete circuit, the electricity can make a complete path. Okay? It's an unbroken path. Of course, we need a power source, a battery or other power source, and we need the circuit to go all the way around. It cannot be broken. Symbols: switch, wires, battery. This is another way to represent a light bulb. We've been using the circle with an X, but that is another way you could do it. A series circuit. What is it? Basically, it is a simple circuit with more than one light bulb in it. Okay, so a series circuit is a complete circuit with only one path for the current to take. There are no other optional roads, other optional wires. There's just one path for the electricity to travel. Some downsides of a series circuit: when one bulb burns out, it breaks the circuit. Bummer. You may have seen this if you have an old string of Christmas lights. You get one light that's burned out and goodbye, they're done. To the trash. If you add resistors, it increases the resistance, which reduces the flow of electrons. So as you add light bulbs or as you add things that use the electricity, it reduces the flow of electrons throughout the rest of the circuit. So as you add resistors, it causes lights to dim, fans to run slower. You get it. You get the idea. As you move along in the circuit, things can only use as much electricity as they are given. What happens when you add more resistance? Well, the flow of electrons decreases. So in the beginning, the electrons are moving quite a bit. And then as you add things to that circuit, they move less and less and less and less. So less light, less movement. You get the idea. So an illustration that shows us what happens, well, when one bulb breaks in the circuit, the electricity is not able to travel to the next light bulb. So the circuit is broken. So that's one of the downsides of a series circuit. Some plus sides of a series circuit: they're simple, they're easy to build, and they are easy to design. Okay, so they're easy, basically. So this shows us when both light bulbs are complete and all the way in their sockets. Yeah, it works. It works great. But if one of those lights goes out, no light. This shows us what this will look like in an illustration. You have your battery, your wires, your light bulbs. Okay, you should be able to illustrate that by now. Another illustration. Okay, so this shows us what it would look like in a picture. You have your battery, your light bulbs in a series, a switch, an open switch, so therefore the lights are not turned on because the switch is open. If the switch was down, it would complete the circuit and the light bulbs would go on. So remember that batteries do not make the electricity. They just get the electrons moving. The electrons are already in the wires, already in the light bulbs. Your power source just gets them moving. Okay. Parallel circuits. The other kind of circuit you really need to know, the light bulbs are in parallel. They're parallel to each other. There are multiple paths for the electricity to flow here. Okay, so what is a parallel circuit? It is a complete circuit with several paths for the electricity to take. Okay, for example, here's our illustration. Electricity flows. It could keep moving on this way, or it could go to this light bulb here. So there's a choice for the electricity to take. Advantages. If one bulb goes out, the others keep working. That's awesome. The total resistance does not change when resistors are added to the circuit. So you could add and continue to add light bulbs upon light bulbs upon light bulbs to this parallel circuit, and it would not dim the other light bulbs. It would not affect them because the electricity has multiple paths to take. There's not just one path for the electricity to flow. Okay? So that is parallel circuit. Here is a picture, and here's a drawing. Okay? Again, light bulbs, circles with an X, and our battery symbol. So, to illustrate some of the advantages, if one light bulb goes out, the other keeps working. It does not matter if there are light bulbs out. The other bulb that is not broken will still keep working. Alright, so identify the circuits. Which is which? Okay, so there's that circuit just turned on. And then there's that one. Okay, notice the difference in brightness. Okay, same amount of power here. Alright, but one is brighter while the other is dimmer because in one there is only one path for the electricity to take. Okay, so when you add resistors, it decreases the electricity to everything. Okay, so this light bulb is turned out, the others are continuing to work. And this light bulb gets unscrewed. The other ones cannot work. Okay, so by now you should be able to identify, oh yeah, hey, these lights are parallel to each other and one is going out, the others are continuing to work. Over here, that is not the case. So you should be able to figure out, let's call this one here, we'll call this circuit A, circuit B. Circuit A is parallel while the other circuit series. Okay. Alright, so you should be able to identify which is which here. Which type of circuit is in your house? Well, parallel. How do you know that? Because if a light burns out in your house, it's not like everyone's stuck in the dark. The others keep working. If you turn on one light, it does not dim all the others in your house. It's not like one is using all the electricity and so the others are not going to work. Resistors can simply be replaced. You can plug things in. That's why Mr. Outlet here is saying, go ahead, add something to my circuit. See what happens. He's kind of a punk. So don't ignore the outlet here. But seriously, if you plug something in, you are adding something to the circuit, but it's not going to make everything else run slower, or it's not going to make the other lights dim. All right. Well, that's it, and that's all. If you have questions, please bring them to class. And remember, go learn the electric slide.